Okay, I want you to think about your flashcards. When you make flashcards and you study what sine, cosine, tangent is, and you look at the front of your flashcards and you say, okay, we're talking about the unit circle. What's the cosine of theta? Well, the back side of that flashcard should say that the cosine of theta is x, and x is your horizontal move, right? X is your horizontal move. And the sine of theta is y, and y is your vertical move. So that's exactly what's happening here. We've got a horizontal component that is equivalent to the cosine of theta, and we've got a vertical component that is equivalent to the sine of theta. This is a unit vector. This is a unit vector. So in the unit vector, you've got the cosine of theta being your horizontal move and the sine of theta being your vertical move. This is component form. So we've got component form, and then on the right, we can also write it as a linear combination. They mean the same thing, just two different ways to write the same exact thing. Now, when we're not dealing with the unit vector, this is a unit vector. When we're not dealing with the unit vector, we've got a magnitude. So when we've got that magnitude, we can multiply that magnitude on the outside of the unit vector, which can also be distributed because that's what you do on a scale with a scalar on the outside of your component form of your vector. When we're looking to find the angle, we are going to divide our vertical divided by our horizontal. So let me just show you this. If, let's just say, for instance, we go right this amount. Let's just say we go right 3. And we go up 1. And that's our vector, right? So our vector in component form is 3, 1. If I want to find the direction of this angle theta, I know it's in quadrant 1, right? So I know it's in quadrant 1. I need to know what this angle is. So my angle in standard position. Well, I'm going to find that angle by making my little right triangle, right? So I've got my right triangle. I know the opposite side is 1. I know the adjacent side is 3. And I'm looking for theta. So opposite over adjacent, that's going to be 1 over 3. I'm going to write it right here. So theta is equal to the inverse tangent of 1 over 3, because when you put your ratio in, you're talking about the inverse function. So this is going to make a lot of sense right here. So we've got the tangent of theta is equal to sine over cosine, which is b over a. The b over a is going to come a little bit more clearer in later videos, but it's the second component, so it's your vertical component over your horizontal component. So we'll do a problem and we'll apply this, and hopefully it'll all kind of fall into place. You need to watch that beginning part again after we do an example. Maybe it'll make more sense then. We want to find the direction of 3i plus 3j. So 3i hat plus 3j hat. Well, you can think of this as component form of 3, 3. I know exactly where that is. That's in quadrant 1. So I already know that this is in quadrant 1. And it happens to be, without me doing any math, it happens to be, there's my vector, it happens to be a 45-degree angle. So I already know that this angle is 45 degrees, or pi over 4. We can do degrees here, so make sure your calculator's in degree mode. We're gonna do this. However, the tangent of theta is going to equal 3 over 3. When we use our calculator, we're going to get a reference angle. So theta reference angle is equal to the inverse tangent of V2 over V1. Now the reason I'm using absolute values is because the reference angle, remember the reference angle is always positive. So I'm going to use absolute values. In case I get a negative value, I'm going to make it positive. So theta reference is equal to, in this case, the inverse tangent of 3 over 3, which is 1. The inverse tangent of 1 is 45 degrees. So I didn't need the absolute value there in this particular case. Because I'm in quadrant 1, because 3i hat plus 3j hat is in the direction of quadrant 1, theta equals 45 degrees. Okay, so we're going to try another one. This one's not going to come out as pretty. We're going to definitely need a calculator for this one. So grab your calculators. We're going to use a calculator. We want to find the direction angle of vector v, 3i hat minus 4j hat. So the first thing I do, step 1, sketch the vector. So right 3 down 4. So right 3 down 4. So this is a little bit closer to the y-axis than it is to the x-axis. I need the direction angle in standard form. So I need that blue angle right there. My reference angle is going to equal the inverse tangent of -4 over 3. I already know that the inverse tangent is going to give me a negative value. So remember that your arctangent or inverse tangent goes from negative 90 degrees to positive 90 degrees. It's quadrants 1 and 4 the short way. So I'm going to get either a positive angle between 0 and 90 or a negative angle between 0 and -90. This is going to give me a negative angle. So when I put this into my calculator, I'm going to get -53, and I'll let you catch up. So make sure that you get this. You're in degree mode, -53.130 degrees. Now, if you did not get a chance to do that, press pause and make sure you go through this process. The absolute value of -53.130 is 53.130. So my reference angle is this angle right here, and it's equal to 53.130 degrees. I need the blue angle. So the blue angle is going to be 360 minus 53.130 degrees. So my direction angle, theta, is equal to, or approximately, 306.870 degrees. That is definitely in quadrant 4. So the direction of this vector is in quadrant 4, and it's 306.870 degrees. Now, it might be helpful for you to go around the circle or around the coordinate plane and write your angles: 0 degrees, 90 degrees, 180, 270, and then 360. And it will make a lot of sense now that, oh, 306 is in quadrant 4. Okay, so these are all about your direction angles being your angles in standard form. Your angles in standard form. Okay, so here's a try. See if you can try this one. And then I'm going to quickly give you the answer. So the first thing you want to do is you want to always plot it. So you want to find out what quadrant you're in. We're going to be in quadrant 2, and we are much closer to y than we are to x. So I assume that my answer, my direction angle, is going to be an angle that's past 90 degrees but closer to 90 than it is to 180. And then my reference angle theta is equal to the absolute value, the inverse tangent of 5 over negative 2. So I get my reference angle equaling 68.199 degrees. So that's this angle right here. So theta reference is this angle right here. If you don't know that, if you don't remember, you might want to go back to the definition of a reference angle. It's a positive acute angle made with the x-axis. So here's our x-axis. It's positive 68, and it's the angle that's made with the x-axis. So we're going to have that portion right there is 68.199. So my direction is going to equal 180 minus 68.199 degrees, so that I get this angle right here, which is approximately 111.801 degrees. So that's our direction angle of the vector v. The next video, we're going to kind of put things together with sine, cosine, linear combination, and then we're going to head towards some word problems. So you'll be able to see these vectors in action. Where do we use these vectors? They're used all around us